more in rapture than the aftermath. In any case, a late disclosure has caused a major split between subject matter experts as they check out the information. Now, the much-anticipated portrayal of clarity has appeared. Also, known astrophysicist Neil deGrasse Tyson uncovers the amazing disclosures in space. Join us as we explore how Trailblazer 1 saw 500 faint items going through space and track down Tyson's viewpoints on this confounding exposure. On June 30, 1908, a stony space rock slammed into Earth, striking a city in Siberia, Russia. The strong impact of this event caused the night out of around 2,000 square kilometers. The impact of this event resonated worldwide, causing a by-and-large shock wave. Research following this event incited the appropriation of the genuine joining between cosmology and the military by Neil deGrasse Tyson, wherein he highlighted the mix of reasonable evaluation and public safety, supporting for increased interest in space exploration to protect our planet. This huge work changed public attention to the importance of space exploration in an overwhelming new development. NASA's space gadget, Wayfarer 1, has recently recognized 500 dull items cruising by in space, leaving experts puzzled. Neil deGrasse Tyson, the shockingly striking astrophysicist, has undoubtedly emerged to give really basic clarity as examiners dove into the secret of these 500 unidentified objects. They coincidentally saw a stunning disclosure about Explorer 1 itself. However, before we look at that disclosure, we should first familiarize ourselves with the Trailblazer 1 rocket. Trailblazer 1, the rocket currently under evaluation, has already ventured an amazing 145 billion miles from Earth. The speed at which the rocket travels through space is truly stupefying, covering a distance normally 3.6 times the space between the Earth and the Sun every year. At any rate, there's another side to the interstellar test. Beyond its speed, future, and distance from Earth, Trailblazer 1 has sent numerous momentous disclosures to us, like the consistent identification of 500 faint items in space. These are difficult to miss, great things that we've never seen or recognized. We'll get into that colossal uncover in a moment. Right now, there's a question that is likely at the very front of your mind. How could a rocket shipped off way back in 1958 still be working and conveying such basic information? Well, the answer lies in the dumbfounding preparation and nature that went into Explorer 1's design. One of the key remarkable features that have expanded its future is its double-access computer systems. Every Explorer rocket, including Traveler 1, was equipped with two plans of request computer subsystems: the Flight Data Subsystems, FDS, and the Attitude Control and Clarification Control Subsystems, AACS. This undeniable, unmistakable tedium goes similarly as a basic protection, taking into consideration unscheduled advancement among systems and the capacity to replace defective computer parts, thereby extending their future. The computer systems on board Traveler 1 and its twin Trailblazer 2 were designed as a distributed system with three twofold obvious redundancy courses of activity of computers. This redundancy ensured that even if one system failed, the other could take over, preventing critical failures. To use limited power sources, the Trailblazer instruments depended upon arranged logic. This means the computer systems were designed with improved circuits to ensure they could work within the power budgets and time limits during the rocket's mission. But power management is critical in maintaining Explorer's integrity. The rocket's distance from the Sun, where it can acquire solar energy, presents a huge challenge to sustaining power efficiency. Engineers had to think about inventive methodologies to conserve and improve power use. The power management technique used by this critical space device is genuinely striking. One major piece of force management involves exactly shutting down unnecessary systems. Experts carefully evaluate what parts or subsystems are not essential for the primary mission goals. For example, radiators associated with certain scientific instruments have been deactivated. These radiators were initially expected to maintain the instruments at specific temperatures for operation. By turning them off, power consumption is significantly reduced, thereby extending the rocket's overall life. This decision to shut down unnecessary systems isn't trifled with. It requires careful assessment of the compromises between power preservation and the scientific objectives of the mission. Engineers work closely with scientists to ensure that deactivating specific systems doesn't compromise the quality or availability of scientific data. The goal is to find a balance that increases power efficiency while maintaining essential functionality. However, that's not all. Explorer 1's power management systems also adapt to the changing conditions of its environment. As the space apparatus ventures farther from the Sun, the available solar energy diminishes. To compensate for this, Explorer 1 adjusts its power consumption accordingly. This adaptable approach ensures that available power resources are effectively allocated to support essential operations and data transmission. Over the years, there have been continuous technical advancements and improvements in power management strategies, allowing scientists to refine and further develop the power systems of the Explorer missions. These updates include more efficient power distribution, improved battery charging strategies, and advancements in power regulation and control. Thanks to these careful power management systems, engineers have successfully extended Explorer 1's operational life, enabling it to continue its scientific journey through the universe. Considering that the rocket was initially expected to last just 5 years, the fact that it's still sending information almost 50 years later is remarkable. It highlights the dedication and capability of the researchers and specialists who have worked tirelessly to keep Explorer 1 functional. Despite this careful preparation and design, the depths of deep space remain unpredictable. Stay tuned, because a crucial revelation is coming. Pioneer 1 found something that amazed experts. While there are several broad theories about what Explorer 1 could have initially encountered, meteoroids, space rocks, and space debris, there is always the potential for astounding discoveries. One such stunning turn in the Trailblazer 1 mission was the shuttle's recognition of 500 puzzling items. This revelation caused a significant stir and raised major concerns among the researchers handling the mission. These bizarre signals and peculiarities in the data came as a complete shock. Explorer 1 began sending telemetry data back to Earth, but the readings were odd, and there was no clear explanation for what was happening. The experts marked this anomaly as a mystery. Despite a few misinterpreted transmissions, Explorer 1 continued to note orders from mission control, but with a slight delay in communication. This was baffling, and it became a mystery. What was especially confusing about this irregularity was that it didn't trigger Explorer 1's initial fault protection systems. These systems are designed to activate when inconsistencies are detected, putting the shuttle into a test mode that allows specialists to explore and analyze the issue. For this case, however, Explorer 1 continued its tasks without entering test mode, adding to the mystery. After thorough evaluation, the anomaly was traced back to the Attitude and Control Subsystem, ACS. The ACS plays a critical role in positioning the spacecraft and controlling its movements. With a 22-minute delay for a radio transmission to travel one way between Earth and Explorer 1, this crucial time delay presents challenges for consistent communication and command execution. Despite these challenges, the mission team successfully carried out the fixed-to-course telemetry data to the onboard computer. However, the process was not without its complications, given the vast distance between Earth and Explorer 1. Even basic communication orders took time to reach the rocket, and the resulting response had a significant delay. Still, the fix was eventually executed, and telemetry data began flowing through the correct channels, providing clearer and more accurate information about the space climate surrounding Explorer 1. With the inconsistency resolved, specialists could now focus on analyzing the data collected by the shuttle. As researchers delved into the telemetry data, they made a confusing revelation. Among the 500 unidentified objects identified by Explorer 1, there was a subset of things showing exceptionally strange qualities. These objects displayed irregular movements, erratic shapes, and peculiar ghost marks unlike any known celestial abnormalities. Initially dismissed as instrumentation errors or noise, further investigation revealed consistent patterns in the behavior of these odd objects. They seemed to challenge conventional explanations and tested existing models of celestial mechanics. Scientists were baffled by the nature and origin of these strange objects. The discovery of these perplexing objects ignited serious debate and speculation within mainstream science. Some experts proposed bold theories, including extraterrestrial intelligence or advanced drive systems, while others maintained a more skeptical position, calling for more conventional explanations. Given these revelations, Neil deGrasse Tyson spoke about the significance of Trailblazer 1's discoveries in a series of interviews and public statements. Tyson emphasized the importance of maintaining scientific rigor and caution while exploring the unknown. He warned against rushing to make premature conclusions and urged scientists to conduct thorough investigations before drawing definitive conclusions. Tyson's measured response to the discovery of the puzzling objects helped temper speculation and promoted a more cautious approach to scientific inquiry. He stressed the need for continued observation, data collection, and analysis to unravel the true nature of these mysterious irregularities. Shortly after the initial discovery, scientists worldwide ramped up efforts to study the extraordinary objects identified by Explorer 1. Observatories, space telescopes, and ground-based instruments were assembled to observe the areas of space where the inconsistencies had been detected, gathering additional data to complement the space-based observations. Gradually, a clearer picture began to emerge as scientists worked to solve the mystery of the peculiar objects. Through careful examination and collaborative research efforts, they uncovered clues about the objects' origins and behaviors. While many questions remain unanswered, each new revelation brought scientists closer to understanding the nature of these vast secrets. As the investigation into the bizarre objects identified by Trailblazer 1 continues, scientists remain focused on unraveling the mysteries of the universe. Their dedication to exploration, discovery, and understanding serves as a testament to the human spirit of curiosity and inquiry. In the end, the discovery of 500 unidentified objects by Trailblazer 1 represents a milestone in the history of space exploration. It has challenged our understanding of the universe and opened new avenues for scientific inquiry. By carefully examining these strange anomalies, researchers hope to uncover the mysterious secrets of the universe and expand our knowledge of its complexity and diversity.